Hi folks, and welcome back to my YouTube channel. This is part 3 of a 10-part series on what is bipolar. Today I'm going to dive into the cellular biology of what is bipolar. And again, I'm not a doctor, I'm not a psychologist, nor a psychiatrist. I am an enterprise architect, a researcher, and a scientist. So this is my understanding, the understanding I've developed over the last several years in understanding what happened to me when I experienced that bipolar rupture and crash that followed. So stay tuned as I dive into my understanding of the cellular biology of bipolar disorder. I promise you it's a radically different view than you've heard before. Thank you. Oh, and if you would, I always forget to do this. Like and subscribe. I've got to get better at that. Please like and subscribe. It's really important. I'm doing this in hope to reach as many people as possible with that story of hope. That's truth, right? That we weren't born this way, but we were broken along the way. And as a result, we can beat bipolar. We can achieve mental health. So like and subscribe. Share this message with others. And if you disagree with me, great. Disagree with me, tell me that. And let's find the truth together. Sound good? Thanks. So before I dive into the cellular biology of what is bipolar, let me ask you a question a little easier to answer that hopefully by the end of this video, you will have a very clear answer for. I like to do this on every video for a couple of reasons. One is hopefully you stick around to the end so that we can answer that question together, but also because I want to challenge you to look at bipolar in a different way, to have a different understanding of bipolar than you did before you started the video. Now, why am I doing that? These understandings of bipolar is what helped me become healthy. So if I can teach them to you and I can show you new ways of looking at bipolar, maybe you can help others or become healthier yourself. So my question is, can you control bipolar? Can you control the states and the transitions of bipolar disorder in your own life? Can the people you care for with bipolar, can they control bipolar? By the end of today's video, I believe you'll have a clear understanding to the answer to that question. And it's a big one because it changes the way we treat bipolar in ourselves and how we treat the people with bipolar in our lives. When I dive into the subject of what is bipolar, especially this area of cellular biology, it's a deep dive. I've had to do a lot of research and I've had to develop an understanding of some things that before I simply didn't understand. And in the description, I have links to information from doctors, researchers, and laboratories that have worked specifically on bipolar. I encourage you to take a look at these links and develop an understanding for yourself. Hopefully in today's video, I'll give you that high-level overview of my understanding of the cellular biology of bipolar disorder. So let me begin with kind of a general overview. First of all, I'm going to go into how, though it is epigenetic and hereditary in nature, bipolar is not a genetic disorder. I'm going to talk about the neurons, gliae, and astrocytes that are critical to the mechanics of what is bipolar disorder, or my understanding of what bipolar disorder is. I'm going to talk about the resting potential and the effects a potassium ion has on neurons and how it prevents those neurons from ever reaching a resting potential. How that mechanism creates this buildup to mania, and how that manic episode or these manic episodes create that epigenetic change to the transport layer of how ions are processed both external to the neuron and within the neuron itself. I'll talk about how that mania, that cascading mania ultimately causes neural transmission shutdown that we understand as depression. And how this together, this inefficiency of clearing potassium ions from around the neurons, create that cycle of mania that we can't break. It's not a cycle of mania and depression, it's a cycle of mania, collapse, and mania. So in today's video, I'm going to dive into each of these areas in some detail, enough so that at the end, we have a clear understanding of my understanding of the biology of bipolar disorder. So stay with me. You know, one of the things I discovered about physical and mental health some time ago is that when they don't want to give us an answer, when they don't really know what's wrong with us, they usually tell us the same thing. Hey, it's genetic. You got it from your mom and dad. You can't do anything about it. It's in your genes. Well, though bipolar disorder is hereditary, they have not found a single genetic link. They haven't found a single gene that makes me being bipolar the same as someone else bipolar. It just doesn't exist. So let's clear that out as a presumption. In fact, I encourage you to just flush it as an idea. You may have gotten bipolar from your parents, but you didn't get it because of genetics. You got it because of epigenetics. You got it because the same type of traumas that existed in your parents get passed into you through behavior, through things that happen in your life. So let's start this understanding with that understanding that researchers, doctors, geneticists have not found a single genetic link to bipolar. So neurons, gliae, and astrocytes. When this whole process started, I had no idea. I mean, I knew what neurons were. Maybe in a push-shove situation, I could have guessed what gliae was, the glue that holds the neurons together. But astrocytes, not a chance. For me to understand what happened to me in bipolar, I had to study all of these. I had to develop an understanding of these systems. So give me a minute to explain them to you, so I can explain from there what happens to these systems with bipolar disorder. So here we have a neuron. We have actually the gliae. Gliae is the substance other than neurons that make up the neural tissue of our body. Some people, this can be 5 to 10 times the amount of neural tissue that there are neurons. It's a very important part of our brain. About half of the gliae falls into a category called astrocytes. Now, astrocytes are what connect the neurons to the blood vessels. It is the blood-brain barrier. It's what allows things from outside the brain to pass into the neurons, and it also cleans things away from the neurons and keeps things tidy. So it's a general maintenance bot, if you will. It goes through and it cleans stuff out, and it provides the nutrients for the individual neurons. Okay, so we have that basic understanding of neurons and astrocytes. Neurons fire and process information, and astrocytes clean up after neurons and provide nutrients to neurons. It's important to go into the process that takes place when the neuron fires in a little bit more detail. So when the neuron fires, several things take place. Now, again, remember, a neuron is simply a cell. And with that cell, there is a cell membrane, right? As we have within this picture. So within that cell membrane, there's the inside of the cell and the outside of the cell. Now, in the case of a neuron, it is the substance inside of the cell and the outside of the cell that gives that neuron a charge. In this case, the inside of the cell is filled with potassium ions, primarily, and the outside of the cell with sodium ions. It is the difference between these potassium ions and sodium ions that gives this charge to the cell, or a charge to the cell. When the cell reaches a certain level of charge, polarization, or if you will, difference between the outside and the inside of the cell, the neuron will fire. Depending on the neuron, that is a voltage of about -55. So what does that mean? About -55 volts polarization between the outside and the inside of the cell. When that threshold is reached, what is called the strike threshold or spike threshold, when that is reached, the neuron will fire. So the neuron fires as a result of an increase in potassium ions outside the cell and an increase of sodium ions inside the cell. Well, actually, interestingly enough, research has shown that it's actually the placement of the potassium ions that really affects that threshold the most. So, with each firing of a neuron, each time that spike threshold is crossed and that neuron is fired, a channel through that membrane is opened up, and a sodium ion passes out of it, and a potassium ion leaves the cell. So a sodium ion goes into the cell, and a potassium ion leaves the cell. When that takes place, that potassium ion outside the cell changes the polarity of the cell, increasing its polarity threshold, that difference in polarity. And as that happens, it closes, repolarizes the cell, closes those channels, and as it drops, it fires the neuron again. And with each firing of the neuron, there is that exchange of sodium and potassium. Sodium and potassium. And as the potassium goes to the outside, that polarity has changed, the voltage is increased, and it is fired again. Well, with each firing of the neuron, the astrocytes, remember, they clear away this buildup of potassium. Well, this is the important part. This is what Dr. Wallace and Dr. Vito discovered. That as a result of the trauma that people with bipolar have experienced and experience within their life, there is a change to the efficiency of that potassium ion clearing process around the neurons, and it actually builds up. So as those potassium ions build up around the neurons, as the astrocytes cannot clear it away efficiently enough, what happens? The neuron begins to fire faster and faster. As the polarity increases on each neuron, as it gets more and more covered with potassium ions, and that polarity increases more and more, with each firing of the neuron, it simply has more potassium ions around it that isn't being cleared efficiently, and that polarization increases, causing it to fire even faster. Ultimately, going into a free firing process, ultimately that polarization increases. Those potassium ions have built up to the point to where that neuron is just perpetually firing. Full-blown psychotic mania. All caused by that sodium potassium pump and those potassium ions not being efficiently cleared from around those neurons. So what do you think happens when that cell fires and fires and fires and fires like that? What happens to its potential to complete the task it's supposed to complete? We'll go into that in just a minute. So as this buildup of potassium ions around the neurons continues, mania continues. That escalation of mania continues because that electronic polarity is continuously being affected by this buildup of potassium ions. ultimately that buildup becomes so severe that the neuron can no longer effectively communicate, and that communication breaks down and collapses. That neuron literally stops firing. It can no longer communicate. When that happens, when that collection of neurons that are now completely inundated with potassium ions starts this cascading shutdown, that's when we experience a CNS collapse and depression. Because whole systems within the central nervous system are collectively affected by this buildup of potassium ions. See, I believe that is where the connection to cluster headaches, epilepsy, and other type of disorders can be found. If trauma is the source of this potassium ion buildup, what other systems are being affected by it? And why does this potassium ion buildup affect these particular neurons? Well, I believe it's because it is those systems that are being affected by the trauma. So as this potassium ion builds up, ultimately it builds up to where the neurons can no longer fire and the CNS collapse or crash takes place and depression is experienced. Now, as a result, those neurons are no longer firing and those astrocytes are continuing to perform their function. Clean up potassium ions and other waste from the cellular process. So, as a result, finally, those cells, they don't reach their rest potential, but they are forced to rest due to neurological collapse. And those potassium ions are being cleared away while that neuron is no longer firing. All right, that feels like a lot of information. Let me take that same information and break it down in a slightly different manner. Let's break it down into the actual way that it affects our bipolar, the actual way that we process those potassium ions. So again, bipolar begins with the onset of mania. Some event, usually caused by trauma, starts this process, starts that manic process. That epigenetic change changes the efficiency of the systems that clear the potassium ion from around the neurons. As the mania increases and these firing of the neurons increases, that situation worsens. More and more potassium ions build up around the neurons, which cause the neurons to fire faster, producing more potassium ions. So as the potassium ions build up around these collection of neurons, that system that is controlled by those neurons is affected, and the communication between those neurons collapses and depression takes hold. Well, as a result of depression, as a result of this neural collapse, that neural activity ceases or slows down dramatically, allowing for an increase in the clearing of the potassium ions. As the potassium ions are cleared, neural activity increases, except because they're never fully cleared, they're always hindered, it immediately returns to a state that begins to build mania. Why? Because those potassium ions never got cleared out. That trauma caused an epigenetic change in the clearing of these potassium ions from around the neurons. So those neurons never really reach a state of rest. They're either fighting potassium ions on the outside in this huge polarity change, causing hyperactivity, or they're in a state of neural collapse and not firing at all. They never really get to enter that state of neurological rest. So do you remember the question I asked you at the beginning of the video? The question I said that at the end, hopefully, based on the information I shared today, we would be able to answer together. The question was, can you control bipolar? So I ask you, based upon what we talked about today, if you believe what I've shared with you is true, that it is a buildup of potassium ions around neurons that actually cause this cascading firing, this out of control hyperactivity of the neuron, do you believe based on that information that somehow you can control bipolar? That somehow it's a condition that you can put parameters around and control with either your mind, or somehow that doctors can control with some concoction of medications? I think we answered that question today, and I think that answer is quite clear. We don't control bipolar. In the worst case, we manage it. To me, the amazing thing is, and that's what this information provides for you here, you don't have to do either. You can beat it. You were not born this way, folks. You were broken along the way. And I am living proof that you do not have to be bipolar. There is hope. And on this channel, I can't heal your bipolar, but I can show you how I found healing for mine. How I prove every day that we don't have to be broken. We can get better. There is healing for that trauma. That process can be changed. If the epigenetics caused it, the epigenetics can fix it. There's hope. There's hope for bipolar. Thank you, folks. Thank you for joining me on this channel. Thank you for letting me share my story, because at the end of the day, that's all this is me sharing with you my story as to how I beat bipolar. Now, it's important to me that I get to share the story with as many people as possible, because that's why I'm doing it. I want to help those with bipolar and those caring for people with bipolar to find that path to being whole, to find that superpower of mental health. So the way you can help me is by liking the video, subscribing to the channel, and providing your comments below. Even if you disagree, even if you don't believe this is how we develop bipolar, great, tell me. Let's learn more together. I beat bipolar, folks. I am confident if you have bipolar, you can too. If you want to beat it, you can beat it too. Thank you, folks. Stay tuned for the next one.